Welcome back to Let's Make a Game, a channel about making computer role-playing games using the free program Twine and the Sugarcube format for Twine. In this video, I will be continuing my series on adapting the fighting fantasy rules to a Twine game, using the Sword and Planet subgenre of science fiction to inspire the setting and plot. So, in my last video, I showed you how I've set it up so that the program will do a large number of simulated plays of the game, or at least of what has been written of the game so far, and it will keep track of how often the player dies, and it will also keep track of which paragraphs the player ended up at which were unwritten. In other words, when the game ended, if the player didn't die, if the player was still, if the character was still alive, where they ended up. But we might also want to know whether a player is going through a particular section that is written. So we might have, for example, in this game, we have a section where you come to the main city of the game, and I have written a few things beyond that paragraph, but it's still possibly worth seeing how many people get to that initial paragraph describing the city, because we want to know how many people are coming to the city in total, compared to how many people are ending the game still in the jungle, or how many people are ending up being captured by the other species that we haven't dealt much with, or sold into slavery to the other human city, etc., etc. Because winning the game requires going to that main city. We might have an idea that, let's say, well, 70% of times a person plays this, roughly speaking, we want them to get to the city, and then the main challenge is the city. Or we might have a lower number. We might say, well, maybe 20% of characters should get to the city. And so, of course, whatever the idea is, there's no point having that aim if we aren't able to compare it to reality. So what I've done is I've coded the ability to keep track of how often the player goes through a particular section, and I'll show you how it works. It's fairly straightforward. We have the initial screen here where we have the options. We can play the game, we can run through the game multiple times, as we did in the last video. We can run through it once just to see that's more just to make sure that the algorithm the computer uses is working and is indeed going through the game properly. Or we've got this new option, which is track section, and that will allow us to do basically what this option allows us to do, but it will have one extra feature, which is that it'll tell us how often the given characters went to a specific paragraph. So if we click that, and let's use the example of the paragraph or section where the character first comes to the main city, which I, having looked at the code, know is paragraph M. So I enter M, and then press return, and it should sort of freeze, because running through the simulated runs of the game, because there's quite a lot of them, it will take a little bit of time to do. But that's not that's not the game crashing or anything. It's just a consequence of the fact that it takes a certain amount of time. So I pressed return. Actually, that time it was a fair bit quicker. I think this Mac that I'm using is probably quicker to process things than the laptop that I usually use, and everything looks basically as it has looked in the last video and the sort of videos before that. The change is down the bottom. So we scroll all the way down the bottom, and when we get the report, we see we have this new element. So it says character 1 died twice, they found section M 3 times, and then it has, as it had before, the places where they ended up. And in fact, we can see, because section M currently only leads to other sections that also start with M. That won't be true in the final version, but at the moment we can actually see what happened in those three. We can see that they ended up at M1 twice and M2 once. And so that one found section M 3 times, that one 5 times, that one 4 times, that one 7 times. So there's a fair bit of variety there. I mean, 7 is, of course, over twice 3. Whether that's whether that's just random chance or whether that reflects a real difference in the characters, we'd probably have to run it a few times and see if the results were consistent. But it is something to look at. We can also see that they're not getting there most of the time. They're only getting there a minority of the time, which might be a concern depending on how often we want them to get there. But we should bear in mind that we have several unfinished sections which are intended to lead to that paragraph. So there's quite a lot of sections that are travelling through the forest, basically on your way to the city. But at the moment, because those sections haven't been written, you will end up with an unfinished. You'll end up at an unfinished section before you reach section M. But when they're finished, that should increase the number of characters who make it. But if we wanted most characters to make it to the city, this would be something to keep an eye on and just make sure that it does go up as we sort of fill in those sections, and also make sure that this difference here, particularly between this character and this character, doesn't continue to to have that gap. Anyway, I would like to show you the code now that allows this to happen. It's fairly straightforward. We do have a few more variables that we need, so I'll show you those. We have a new page, track section, and we have some changes on the page one-off. So let's zoom in a little bit and firstly look at the new variables. So we have SE, which is what section we are going to look out for. So if we don't choose to track the section, if we choose to play it or do any of the other options, these variables won't be used. But so SE is which section we're looking out for. So in the example that I showed you then, it would be the text lowercase m. If we want a section with a more complicated name, as you've probably seen, it will often be something like 1AXS or something like that. One of the problems, something I probably should code but haven't yet, is making sure that that section exists. At the moment, it'll just look out for that section. It doesn't first. What it should do is probably check that that section is really a section, and then if it isn't, loop back to the first window and make you enter something again. But at the moment, it won't. It'll just go. It'll just take whatever you enter and look for it, and then report, of course, that you haven't. That all of the characters got there 0 times. SE is what we're looking for. SF is a temporary variable, which is either 0 or 1. It's set to 1 when a character reaches the section stored in SE, and then it's reset to 0 at the start of every run through. And then we have SS, which is how often. It's an array, and as it says down here, $SS square bracket $Z end square bracket is how often character Z reached section SE. So each run through will set SF to 0, set it to 1 if they do reach that section, and then add whatever value SF has, 0 or 1, to the relevant slot in SS to be reported on at the end. Let's go to track section. This is very straightforward. It's just a text box, or a bit of text and some text box. Enter the paragraph to track and press return/enter. And then we have this text box, which is text box $SE, which is the variable that we are writing the input into. And it has to be, notice that it has to be in quotation marks. Then we have this empty quote. This is the text that is pre-filled in the text box. And we have to have that because we also have the destination to go to once we press return, which is multi. If we didn't put this one in, it would think that multi was the text to pre-fill. So that's why we do that. So actually, this is probably not the right. Oh, well, no, I'll show you the order. So we have the for loop. We've seen this code before, so I won't go through every single one of it. But we have a for loop, or two for loops, one inside the other, one nested inside the other, as they say. One is which character we're dealing with, and then the other one is just however many repetitions we're dealing with of that character, however many runs through with that character. We go to generate a character, then we go to one off, which is this one, and I'll show you what's in there and then come back and show you this bit because that's how it would work. That's the actual flow of the program. So we go to one off, we set SF to 0. That's the one that's going to be set to 1 if it reaches the value that we've set in SE. And that is just done here. If TZ is equal to $SE, then set SF equal to 1. Now, usually SE will be undefined because SE is only given a value here. And if we decide to just do a multiple run without that, then it won't ever have a value. But that's okay because the program can look at these two values and see that, okay, TZ has a value of 3M or whatever. SE has a value of undefined. Okay, they're not equal. That's fine. So it doesn't generate an error. Referring to an undefined variable doesn't generate an error. So it doesn't matter that this will be this if will be looked at even though SE often won't have a value. The program can handle that quite easily. So once we've finished going through the run through, we will go back to multi and we set SS TY, i.e. the relevant slot of the SS array, plus equals SF. So SF is always either 0 or 1. So if it's 0, well, that doesn't do anything. It just adds 0, so it doesn't change it. Or if SF is 1, then it adds 1. And this stuff is all things that we've already looked at. And the only other thing we needed to change is this. When we're reporting the details, we have this if def $SE, so IF space DEF space $SE. In other words, if SE has a defined value, then, and only then, we should print this character TY found section SE SS TY times. So something like character 2 found section M or B3 or whatever it might be, 7 times, something like that. And I've put it in bold tags just because it's having alternating bold and not bold makes it a bit easier to see the to sort of separate the sections into characters, I think, anyway. And that's what we do. And so having done that, we can now pick a paragraph or a section and see how often the character is being funneled through that. And then, of course, we would alter the game if that was too high or too low, or if we found that different characters were getting different results and that wasn't something we wanted. Of course, it might be something that we do want. Only the overall balance has to be, well, even that doesn't have to be, but usually you'd want the overall balance to be about the same. But that doesn't mean that you want the characters going to necessarily the same places. You might have a fantasy game where there's a particular path that wizards are more likely to end up on because there's particular events that happen to wizards and push them in that direction. You might have another path that is more likely for warrior types to go because there's events specific to warriors that push them on that path, and that's fine as long as it's intended, of course. That it's more about the overall balance. But I don't really have any idea like that. I sort of have, I guess, that there's not a particular section that I think is for specific characters. There's specific advantages and disadvantages that might pop up, but I'm sort of doing them as I think of them, and it's not with that idea that there's kind of a warrior path or a wizard path or whatever. But if there is, then that's perfectly fine. But again, you would want to test that to make sure that really was happening. So that is probably the last change that I'll make to the sort of testing part of this program. I suspect I'll probably be updating the actual game and sort of reporting on that before I do anything more about the testing. But for now, I hope that was useful or interesting to at least some of you, and I hope you will tune in next time.